And we need to switch around.
Okay. It's good? Okay.
Just try to move the presentation.
Yeah. Alright. That should work. Let me just set my clock.
And what's your name?
Bartosz.
Bartosz. Is that what the unit testing or the?
Yeah, it starts from unit testing and goes a bit to system testing.
Okay.
But it's pretty much basic principles and practices.
Could you move the presentation?
Sure, sure. Should work. Good.
I'm expecting to slow this down.
Well,
Let's welcome Bartosz, and I think everybody's looking forward to see about the testing make software better.
okay, mic check. I'm not sure if, yeah, you can hear me anyway. So hello everyone, thanks a lot for coming. It was quite a maze for me. I had to ask like 2 people to get here, so I'm very happy to see so many faces. When I was giving this talk the first time, it was pretty much full of pain and frustration, tears and blood, and losing hope. But I think we are in a country where beer is the main drink. Maybe not in this area, you're more about wine, I think. So the theme will be beer, because beer is good for everything. And it will be about testing. I'm mainly a Java guy, so the examples I have for you will be in Java. However, I think that the principles and practices I'm going to show you, you can also apply in the other languages, and hopefully with what I will present today, you will be able to write easy, readable, awesome tests and have fun doing so. All right, so let's start with the simple things first. Assertions. This is pretty much the thing which we have in most of the tests, because we test for state as well as behavior, but tests with assertions are pretty much the most popular ones. So the first part will be focused on assertions. So let's have a look at the first example. So the first example is the test where I interact with some repository trying to find the strongest beer in the world. You can see it might be a bit unusual for Java people because I'm not using camel case for test method names. Because test methods or tests in general, for me, they should tell the story. So the name of the test, yeah?
Can you make it a little bit bigger?
I'll try.
Or do you think it's going well?
Yeah, it's easier to ask.
I'm not sure. Well, it's 500 and it's still. Unfortunately, I cannot. I'm sorry about that. At least not in a few seconds. I probably can rebuild the presentation and then make it bigger, but for now, I'm sorry for that. But anyway, so I tend to give the descriptive long names, and I prefer to do it with the underscores for several reasons. First of all, the camel case doesn't read well when the descriptive name is so long, and if we stick with regular Java testing frameworks, we use test methods as a description for what is the feature we are testing. And another good reason to do so is that it's very easy to find the stack trace. So for these 2 reasons, I really favor using underscores, even though most of the people I work with were very skeptical at the beginning because it breaks the conventions, right? Okay, then the structure follows a bit of a BDD besides given. So normally the BDD has, for example, given, when, then blocks, which is coming from Gherkin syntax, where given is an initial context of your test where you set your expected results and the context of the test. Then when is where you actually exercise your component under test. And then in the then block, you either assert the state or you verify the behavior if you use mocking frameworks. So having said that, There are better tools to write BDD in Java, in Go, in .NET, everywhere. But I will stick to the JUnit-like syntax for the moment. If you are looking for more expressive frameworks and you're a Java guy, don't hesitate to look at, for example, EasyB or Spock. These are both Groovy frameworks. Or even Kotlin has a very nice spec framework, which is also very nicely structured. Going back to the simple example I have, there is already at least one problem here, that we use basic assertions which are available in the testing framework, and this gives a narrative of the test a bit hard to follow, because you need to kind of dig into the whole context here and figure out what's actually the subject of the test, and also you might mix the order of expected and actual, and then errors in the tests are becoming kind of tricky. So this beer in particular is real. It's 67.5%, comes from Scotland. Never tried. I'm not sure if I will. But how can we fix it? So if we would have more tests like that with similar pattern of assertions, the first thing which people tend to do is to make a common extract a method and just give it some different name and just pass all the parameters. And this obviously follows the dry principle, so don't repeat yourself. But as I said, I like to break conventions, and I don't really follow dry in the test at all. Because as I said at the beginning, the test should tell the story. So it's easier for me when I look at the feature within the method and I see exactly what I'm testing, rather than having something which will let me jump to this method and figure out what those values are standing for. But that's already a small improvement. What we can do better, however, is to use custom assertions. There are a plethora of frameworks in Java, also in other languages, which let you do so. So one of my favorite is AssertJ, and this gives you fluent interface or a DSL where you can actually say exactly what you're testing. This is a custom assertion which some of you might think it might be tedious to write by hand. However, AssertJ comes with plugins for generating those. So you can, if you use Maven or Gradle, you can just have a step in your build which will do it, or you can have an IDE plugin which will do the same for you. But the main principle here, the main idea is that having this kind of approach gives you a very good understanding what is the subject of the test, rather than verifying a lot of assertions and trying to figure out what the author had, what was the purpose of the test for which the other person was writing. So let's go to a bit of a more sophisticated example. Not that much, but still we probably, having a repository, would like to assert collections. And this is, again, the regular pattern, 5 assert equals, already something which is very smelly, because you shouldn't have that many, as this introduces not only a noise, but also introduces an issue where one of those on the way will fail. Because that would lead to some sort of a snowball effect, trying to figure out what's the issue and fixing one step after the other. With AssertJ, we can do it a bit easier. It has assertions for collections built in. So what we can say, as you see in this example, in the previous one, what I'm doing, I'm actually getting each of the elements and extracting the name and comparing it to what I'm expecting to have. These are actually Czech beers, which I tried over the weekend. Pretty good. What we can do if we are not in Java 8 yet, we can have an extracting method, which will get the name. Obviously, it's not refactoring friendly, but it gives already slightly better structure. If we do use Java 8, and if you are Java guys, you all should, because it's going to be deprecated anytime soon when Java 9 eventually be publicly available, we can use a method reference. And I was thinking when preparing this example to put Pilsner Urquell as well, because that's not a Czech beer anymore. It's owned by a Japanese company, but still produced here, so I put the Slovakian ones I know. Still, the problem here again is that if we will have size bigger than 4, it will fail. We won't be able to reach this assertion. what we can do with assert J is to use soft assertions, and this just gives 2 extra lines if we don't use JUnit, and then it will be all grouped and reported at once. If we use JUnit, however, we can use a rule, and then the assertions look pretty much the same as the previous example. So I highly recommend using assert J. This makes your life very easy, and it has a lot of other interesting features. Question, yeah?
Not much on the actual Java part, but on the structure of the assertions. What would be the benefit of like verifying multiple assertions at once instead of, for example, stopping on the first one? Because if, for example, in this case, the size would not be the one that we expect.
Yeah.
The test following after that could also be meaningless at that point. So
exactly. It's actually, this one is, maybe not this one, but the previous one when I had all the 4 beers I was checking, it's a bit redundant, that's true. One of the principles, so the question was, does it make sense to have 2 assertions in one test, which one fail actually eliminates the need of another, or actually the second one makes the first one redundant, right? That was the question.
Almost, because it's not making the second one redundant. It's the fact that if the first fails, the other ones most probably are going to fail in the same way. So they're like adding noise to make
sure, that's a very valid point. So normally the good principle is to have one aspect or one functionality per test, and this normally boils down to one assertion. And this is what we should follow, that's true. I mean, these are not perfect examples, I agree. I just wanted to show in the smaller snippets what kind of features there are. But normally, you are correct, one assertion per test should do the job, especially in unit tests. That's totally correct. If you really have to have more than one, then the soft assertion will help you, because then it will group all the issues all together, so you don't have to repeat the test one execution after the other to figure out if the next assertion is failing or not. So, but normally, as a rule of thumb, one assertion, one functionality per test should do the job. And another pitfall or another smell I've seen so many times is that you test some logic, you throw in assertion, then you test something related, you throw another assertion, and this is obviously a candidate to refactor to 2 different tests, because these are 2 different functionalities. So thanks for this question. Yeah, the example is not perfect, but maybe it was provoking to have this question as well. So the other cool things we have, as I mentioned, is a code generation, so you don't really have to write all your custom assertions for your business object, for example, by hand. You can use the scaffolding and then adjust it if you want. So maybe the names which the generator provides are not what you like, they are not too descriptive, you can refactor, but it's a good starting point. And it also comes with the automatic conversion. So if you have already a project with a lot of JUnit, TestNG assertions, or FAST, which was the predecessor of assert J, assert J provides a tool to convert them on the fly. So you can introduce very easily a new way of writing assertions if you like assert J. And on top of that, it comes with quite a bit of plugins. If you use, for example, collections from Guava, which are not the standard ones like multi-maps and so on, there is a plugin for that. If you use JODA-Time, then you also are covered. Then for database testing or Neo4j, there's also a custom one. If somebody writes swing, then there is also a plugin for dealing with swing using assert J. For me, the main benefit of using assert J is actually code completion. There is another very popular framework which is called Hamcrest, and it also gives you a very nice way of structuring your tests or assertions, which you can read pretty much like a natural language. My personal problem with it is that it's all based on static factory methods for Hamcrest, and then you onion them. You can say like is equal to something, but you lose the support from IDE. Whereas in assert J, you have an entry factory method which gives you assertion aware of the type you are testing. So you have a support from IDE showing you exactly what you can verify with a given object. And on top of that, it also reads very natural, at least from my perspective. So that's pretty brief introduction to assertions. The key takeout for me is that we should write the tests that have a story, there are narrative, that assertions are oriented on your business domain you are testing, and assert J gives you this capability pretty much out of the box. What we also should do in unit testing especially is not only to test happy paths like my examples were showing, but we should also think about boundary conditions. And one of the boundary conditions are error tests. So testing how our application behaves when we pass some wrong values, or if we have a correct exception handling and so on. So a test taken from one of the projects I've been working for, obviously not the same business domain, actually had some sort of a BDD flow. It was very, very hard to read because first and foremost you have try, which gives a noise, and then you have this very smelly return in the catch block, and then there is fail at the end. The easiest way to fix it is to do as recommended or as logical by using fail method from JUnit, for example. Pretty much you try where this is a method which is expecting to throw the exception, and if the next line is reached, then you just call fail. This is already not so bad. There is still try, which introduces some noise. So there are tools which can let you do it better. If we look at JUnit in particular, you can test for exception just by defining it in the annotation. And personally, I think we shouldn't use it. Because we don't really know obviously these are 2 lines of code, but sometimes it's a bit more than that. We don't really know at which point the exception is expected to be thrown. And if we don't have our own custom exceptions, or we use type which is too broad, we don't really know what happens, right? So expected exceptions by using just a test annotation from JUnit is something we should avoid. And therefore, JUnit comes with the rule, which is called expected exception. And this thing lets you be more concrete, lets you set your expectations closer to where the error can occur. I've seen people setting it up at the beginning of the test, and this is a bit risky because it might happen that something on the way can throw similar exception, and then you don't really know what happened. So if you want to use expected exception, then rule of thumb is to put it as close as possible to the method which actually can cause the error we are testing for. So we not only can specify the type of exception, we can also specify the method we are expecting. But we have better tools for that. If we are before Java 8, there is a small library which is called catch exception, and this pretty much proxies our component under test and lets us inspect in a more narrative way what was the problem with or what was the error our component under test thrown. It's great, except that the author stopped maintaining it when Java 8 came out because he said with Java 8 it can be fixed with just 1 lambda and makes this library obsolete. So with AssertJ again, we can do it in 2 ways. It pretty much boils down to the same, depends from which angle you want to look at it. You can say assert that thrown by, and then you give the lambda block, and then you verify the exception, or you do it from the other angle. You assert that the exception is thrown by with the message. You have 2 ways, depends on your personal taste. I think this is the most concise for me and most readable way, and it tells exactly what we are expecting from this to happen. For non-Java guys, it might look a bit awkward, I guess, but from my personal experience, that's the cleanest way of writing this kind of error tests. Question?
Shouldn't it be the creating of the beer outside of the assertion so you can distinguish which part
Sure, absolutely. You can put the given block, which will be your stimulus to your test, out of the sure, absolutely, that's right. And then you only have exactly the failure point wrapped in the lambda, right? Sure. The next anti-pattern or common way of dealing with asynchronous asynchronous calls is something I would like to spend a bit time on. So we can look at another example again about the beers. We can have a service which places the order, and this might be asynchronous. So this approach will immediately fail because might be that this state was not updated yet. It's not really a unit test because normally we would probably mock it, so we would get an instant answer. But if we go a bit higher than unit tests, we will face some cases where asynchronous calls will be taking part of. So the easiest and naive way is to just sleep, right? We just wait 200 milliseconds, works on my machine, we push to Jenkins, for example, and then it fails. So what we do? We increase to 1 second. It looks funny, it looks probably embarrassing, but I've seen it so many times that I really thought it's important to spend at least 1 minute on this topic. And also you can see it in UI tests, for example. Probably UI tests are those where you see it the most. So we can make it better with one tiny library, but before I show you one last word about this approach is that we pretty much expand our build time by 1 second each and every time we invoke it, which is first of all not needed, and second of all pretty smelly and painful. There is a little library for Java which is called awaitility, and this gives you a way of wrapping your call and then, for example, polling it for 2 seconds until the condition is satisfied. Reach probably better, won't wait 2 seconds until it's finished. By default it polls every 100 milliseconds, I guess, but then it's closer to the real response than putting a brutal thread slap in the code, thread sleep. And this is what I was referring to before to Hamcrest. These are the static methods which you, as I call it, onion, and it's readable more like a natural language. If you like to use AssertJ again, you can do that. The library provides also a way of doing it by just passing a lambda with verification. So if you have to deal with asynchronous calls, forget about thread sleep. For simple cases and for UI test, awaitility, which boils down to one line of code eventually, will do the job for you, and your test will be less flaky, faster, and way more readable. Additional benefits from awaitility is that it actually is able to detect deadlocks. On top of that, you don't need to have this fixed polling mechanism which polls every 100 milliseconds. If you know you are dealing with something more sophisticated, you can use maybe Fibonacci sequence, you can use an iterative, so every polling will be multiplied by 2. Or if you want to do something more fancy, there is also a very easy SPI to do so. So if you will need to deal with asynchronicity, definitely highly recommend this library. It's very tiny, small jar, not a lot of magic, and tests are way more readable. Your friends from the project will thank you after some time for sure. Okay, let's jump a bit to the higher level of tests, and let's talk a bit about testing REST endpoints. So again, we have an endpoint which returns strongest beers. Let's say I have just those 3 I'm aware of. I'm not sure if you see it clearly, but this is the actual bottle of this beer. Not produced anymore, it was wrapped in squirrels. A Scottish brewery called Brewdog. Okay, so the thing you can see pretty frequently is to use, for example, Apache HTTP client. Again, taken from one of the projects I was working in. So we have initial context where we just set a get call, then we set the client, then we need to do something with the response, so we unwrap the body, we can check the status, and then we need to do something with, if it's JSON, with return JSON, and then assert on the elements of this response. And then obviously at the end, we have to clean up the connection, otherwise we might end up with some memory leaks. So there are several problems here. First of all, it's not really clear what's going on. There's a lot of levels of abstraction, which introduces noise. So the test doesn't tell the story the right way. There is a very nice library which is designed for testing REST endpoints. I mean, I've seen people using it for just interaction with REST endpoints, but I wouldn't recommend because it's quite, maybe not heavy, but it uses Groovy underneath, which normally you don't need to, especially when Groovy is used for asserting. You don't need to bring so many dependencies to just interact with REST resources. But for testing purposes, it actually provides you a behavior-driven way of defining what is the interaction and what would we like to know about the response. And personally, for me, it's way easier, and it tells exactly what's going on. If you compare it with the previous example, we have probably like 3-4 times more lines of code, and this is doing exactly the same thing. Again, what we can do, we can assert on the status, and then there are several ways I will show in the follow-up examples what we can do with the content. The easiest thing, which is probably too happy case, is we can assert on the sites. What we can also do is obviously having some query params. We can also do the testing for example, limit on the return collection. Here there is a convenient method which is called param, and this will be then inferred based on the HTTP method called either to query or path params. But if you want to be more verbose or more precise, there's query param and path param available as well. And then there is, if we deal with JSON, it provides some sort of a JSON path expression where we can just extract all the names and verify the content of it. We can do better things with verifying the content. As I said, it comes with Groovy, so even though it's a string, in some IDEs you can inject support for the given language. This is gpath, which comes from Groovy, and gpath, you can think about it like similar to XPath. It basically is expression language which lets you interact or inspect the structured data. So it works with XML, it works with JSON out of the box. Here what you see, I call the find all method, which is the method available on this structured data with some condition on it, and then I can call a size, for example, and I can verify the content. So if you have a bit bigger payloads or bigger responses, there is a pretty convenient way of verifying those as well. But obviously, sometimes something can go wrong, so we can log what's going on. We can log pretty much everything what's concerned about the requests, params, body, cookies, method, path, or everything. And the same for response. Whereas in response, we can actually leave some of the logging for the tests because the previous request logging is probably only useful when you have a test failure and you want to see what's going on. Then I normally remove it because it's a noise and log will be super huge in your build or in your CI environment. Whereas for responses, you can actually have some conditional logging for status or validation failures, or if you have some custom matchers. Just the tip of an iceberg. The other interesting things we have in Rest Assured, we can have a request specification, so we can have one shared request spec when we have, for example, authentication or some other common elements extracted in the setup method, and we can share it across all the calls in our test. This will give us cleaner tests, less duplication, and reusable request spec. We can have custom parsers, so if we return something which is different than JSON or XML, this can be used to handle this use case. SSL support, and we have filters which let you do something like intercepting request response, doing some things with authentication, with logging, or maybe session management. That's fine. So yeah, highly recommend using REST Assured. Very good library for testing, very descriptive, and also very helpful when it comes to debugging and analyzing what's going on. Okay, let's go one step further then, because the previous example of interacting with REST resources was more thought about having calls to your own components. But what about the case when we have to integrate with the third-party services? So we can, for example, have a rate beer service, which is a website for rating the beers, and we can check if our client code actually works as it should. But there are certain problems about it. For example, we might not have a network, or network might not be reliable. We can have a limit on the API calls. We can have some other random things because the component we are interacting with underneath is not under our control. So how we should deal with that? We can have our own fake HTTP server. So we can stop responses, we can have quite a bit of boilerplate code to do it. But this probably is good as a first step. The issue with this approach is that we might not really reflect the reality. So the headers and the content is just our understanding, and we will have to maintain it having the knowledge of the third-party service. So good as a start, but probably not good in the long run. So we can mock HTTP layer as well. But then again, we are testing in the setup where this is our understanding of how the things are working. And we are not really sure if the contract between us as a consumer and the provider is still guaranteed, it's still respected. So one of the approaches which you can consider is so-called service virtualization. So we'll be showing Java examples, but there are tools in Ruby, there are tools in JavaScript to do the same. The idea is that you can have some, how to call it, like a thin proxy in between, which will let you go to the real service, but on the way it will record it, and then the next time you run, it will pretty much just use what you have. So in JavaScript there is a tool called Prism. In Go language there is a tool called VHS. The inspiration comes from Ruby. It was VCR, I think. That was the name of the testing tool. So in Java we are a bit better than Groovy. We have Betamax, for example. There is also a tool which is called WireMock, which can be used for exactly the same purpose. But with Betamax you have just a tiny little annotation, and the magic happens underneath if you use JUnit. So Betamax has a concept of tapes. So this is the name of the tape, which is pretty much just a file storage with all the interaction happening between us and the third-party service. It works as a transparent proxy if we set up the JVM correctly. If not, then you have a way of just having a HTTP client which will serve the same purpose. So the tape is just a YAML file. It has everything captured. You can also have some regular expressions. It handles the binary content as well. And then we have several strategies. We can have read-write, which was what I was explaining before. So the first call, if there is nothing, will go to the real service. Then on the way back, it will be persisted. So the subsequent runs will be using what we have in the local storage. Then there is read-only, which means we assume we know what's going on. There is no network probably, so we can use it just with our isolated environment. The write-only will just overwrite everything. And then there is another two cases, read sequential and write sequential. This will just go over the whole tape and without any matching will reply the request responses. So one tool for doing service virtualization, fairly lightweight, quite simple, but for a lot of cases very usable. If you want to have more control, then WireMock might be the better choice for you. Okay, then let's talk about the UI tests, as we are going higher and higher in the testing pyramid, which I personally don't believe we should use as a silver bullet or the hierarchy of tests blindly, but it's a good starting point to think about the amount of tests in your project. So the UI tests, most of the times, even if you are not a Java guy, you use WebDriver. So Selenium WebDriver, which are now the same things. So yeah, again, the example of the tests, which I've seen pretty frequently in the projects, which I would assume came from Selenium Firefox IDE, which lets you record and gives very low-level operations on the browser, on the DOM, and this is just not readable. Just terrible code, right? We have thread sleep, which I was talking about, some magical IDs. We don't really know what's going on except of the name of the test itself. And then, I'm not sure if you know what this 13 should be doing. It's pressing enter, right? But yeah, it's probably not the right way of writing your test. I mean, might work at the beginning, but as the project evolves and people are changing, you will probably delete those tests afterwards, so there's no benefit of having such beasts in your code base. So something which is actually suggested by Selenium WebDriver folks is to use page object patterns. How many of you have heard about page objects? Just a few. So basically the idea is that you introduce classes, a hierarchy of classes which model your UI, and this is what you use in the test itself. So it abstracts away what is the interaction with the browser, because WebDriver is not really a testing tool, it's a browser automation tool. So page objects will give you a way of structuring your components and hide the complexity of your tests in those and expose the interaction with your web app through some meaningful methods which actually describe more what user is doing, but not what browser is doing, and that's the main purpose of it. So if we would look at the slightly rewritten test, I think it's a bit nicer to follow what's going on. So we create the page which is encapsulating our website. We need to pass a driver, which is the WebDriver object, a URL where we would like to, which we would like to use in the browser. But then all the other interactions are described more in the way of how user would do it. If we pick into the class itself, it's just a simple encapsulation with the way how to locate the elements and then how to interact with them. But again, you can reuse them across all your tests and you hide the nitty-gritty details, so the tests are telling the story, almost. My personal experience with page objects over the time with the not so big team, different skills, is that it's getting very hard to maintain. And it can result in God objects. So you can have an object which represents the page with everything what's in the page, and then it's like 2,000 lines of code, and you will be lost after a while trying to figure out what's going on when the test fails, and UI tests tend to be flaky, unfortunately. And on top of it, it actually violates single responsibility principle, because if you look at the class itself, it first defines how the elements should be located and then encapsulates the interaction with it. And then on top of it, as I said, the test should tell the story. But who am I in this test? Am I a browser? A page? Well, I mean, it's a great starting point, but people who are strongly involved in acceptance test-driven development, they came up with a better idea. Some of the shortcomings of page objects, like for example, huge classes with a lot of logic responsible for finding elements, this can be solved with another frameworks built on top of WebDriver, which lets you define page fragments, and then you can slice your websites to smaller bits and then reuse them, so you might not have an insane hierarchy of classes and insane amount of web elements, which are the smallest bits of WebDriver DOM representation, but you can mix some smaller fragments and reuse them, like for example, calendar widget or whatever. So there are things which are making it nicer. There's obviously, as I said, WebDriver is a browser automation tool. There is a lot of nice tools built on top of it, which makes you write tests more concise and more user-oriented. For example, from Groovy there is Gap. There is a lot of Sane IDs, another one which is more oriented towards testing the page rather than clicking and opening. But another approach to fix it is some evolution of page objects, which is called journey or screenplay pattern. And the whole idea behind it is that its user is the entity of your test, is the key point of the test, and you see exactly that the user plays a role. There is no browser open, no page search for, and so on and so forth. Another idea which it promotes is that the components are small and reusable, and they are highly readable. At least that's what they say. The code is a bit small, so I'm not sure if you can see from the back, but what it says is, given that Bartosz was able to start the app, when I attempt to search, then I should see that it has this item. So there are frameworks which actually gives you those small building blocks, and then the test will be written in this DSL fashion. If we look at this part, which is still hiding the real interaction, the page, the journey pattern has roles, has actors, has tasks and actions underneath. So these attempts to can be broken down to entering the value into the search field, or hit the return or enter key on the search field. Obviously, you would like to probably hide it because this is not the appropriate level of abstraction, but the key point here is that you have those small components which you can build together and have tests saying some story, actually. So as an example, there is a Serenity BDD framework which came from Java, and now there is JavaScript version using protractor underneath. If you would like to know a bit more, because actually it's the topic for the whole presentation, that's a short link explaining all the details and all the ideas behind this evolution of page objects. And that's pretty much all what I wanted to share with you. So just as a recap, if you write tests, do it well or don't do it at all. Because if you write ugly tests, flaky tests, there is no benefit, delete it, because it will just cause problems and it will add time to evolving the project. So tests should tell the story. One way of using it or doing so is to have custom assertions. Strongly encouraged to avoid wrong abstractions and boilerplate. And from my perspective, tests should be readable, they should be repeatable, and probably most importantly, reliable. And that's all I've got. I'm Bartosz Majsak. I work for Red Hat in DevTools. Tell me your thoughts about the talk. That's my Twitter handle. If you want to see what I'm hacking, that's my GitHub. I'm originally from Poland. So thanks a lot for staying with me. We still have 7 minutes, I guess, so I'm open for questions.
Can you show how is it possible to create custom assertions, or how is it achieved?
So probably won't be able to show it now. The question is, can I show how to create custom assertions? not ready for live coding, but what I normally do, not only for custom assertions, but even for tests when I want to have some DSL, I just write the test in the way I want to read it, and then I implement it. But for custom assertion in particular, assert.j comes with the generator. So you define an object you want to have a custom assertion for, and then it will go over all the fields and will generate the methods like has name, has age, has something. And it's very similar, like you think about builder pattern generators for IDE. You have for Eclipse, you have for IDEA and so on. Visual Studio has it for sure as well. But normally my take is I just write it the way I want it to have. I have compilation errors obviously, but then I implement it. It doesn't take so long, requires a bit of discipline, but it pays off dramatically.
Well, isn't it like that then you need tests for tests?
No. I mean, these are so simple that normally you don't, I think. But that's a valid point. I mean, testing your tests, yeah, it's another interesting topic I could...
You know, if you said that I write it the way I want to read it, and then I implement it.
Yeah.
Well,
sure, but I mean, it boils down actually to reusing existing assertions. Right? Most of the times you end up with some primitive types or some collections, and these you have are already out of the box in those libraries. And there is no point of testing these libraries, assuming that they are tested well, right? About testing your tests, there is an interesting topic about mutation testing, but that's another thing probably for another talk. But if you are interested about the crazy idea of testing your tests, have a look at mutation testing concept. Okay, thanks a lot, and have a nice time. Hi.
I actually have a question about testing REST services. You mentioned it. What do you think? What is the best practice to like test REST services? Suppose I am developing a REST service and I want to write tests. So these tests were running with my unit tests. But
So you are developing the REST endpoint.
Yeah.
Right? So what I was normally doing, or I normally do, is I test the components which are served then as the REST resource as a unit test. So the business logic, everything, and then I have few of the happy paths and some boundary conditions as a black box test for the REST API. So that's normally what I do. There is another interesting concept for doing that, which is called contract-driven tests. So when you have a producer and consumer, you define the contract between them, and then provider, so your REST resource will need to comply to it at some point, right? You need to implement what are the expected behavior or expected payload or whatever, but this you can use even before your REST resource is implemented from the client, because you agree on how the interaction will be going on, right? So that's not a new concept, because I mean SOAP had the same with contract first approach. Just nowadays there's more and more tools. So if you are not only Java, then Pact is one of the tools which is providing that, and it works for JVM, it works for Go, it works for JavaScript, and I think for .NET. And this is all about contract testing. So you define the contract, interaction, how it should be, then provider will eventually comply to it, but client can start implementation of its own, because it's like a mocked or stopped request response. Okay.
But how to organize it? That if I would like to test REST service, it should be deployed somehow. How do you automate that stuff?
So if you use these tools for contracts, or even stubbing it with WireMock, you don't need to, because you just are interested in the payload, right? So this you can store. Other than that, yeah, well, there are tools for...
if you're using REST assured, you should have deployed.
Yeah, so normally what we were doing, we were just deploying it automatically with some predefined set of domain data, and we're just having. These are not integration tests, but subsystem tests. Let's say.
So it's basically you are testing it already in continuous integration server,
Yeah.
not on your machine.
Also on my machine, because there are tools which let you start all this stuff straight from the test.
For example.
Come to my talk at 3 p.m. I'll show.
Oh, great.
Hopefully, this demo will be working, but
Okay.
we'll see. Okay, cool. So one done, one more to go.
Ja myslím, že těž to někdy v škole tam má být minimálně 2.
A právě proto, že tam já to mám být sám, právě protože ten
No, v pohodě.
tak si to dělám zněl. Takže zaprvé.
Tak ty, co přijdu dělat, ty že to bude, no.
Super, děkuji.
How was your talk?
I don't know, you tell me.
I was not sure, sorry.
Okay. Well, I said what I was planning to, so I lost only 2 guys. Had some questions. I will watch it later and I tell you. Or you watch it and you tell me. Okay, thanks
But
a
a
lot.
real nice presentation and
Thanks a
really
lot.
good examples.
Cool, thank you. Glad to hear that. So see you in an hour, right?
I will probably switch to the different
Okay.
session because I will not be here.
Okay.
Maybe we might meet at the end.
Okay,
Yes.
thanks a lot for reminding me about repeating the questions because I always forget and keeping the time. Cool, then see you in a bit.
Thanks. Bye.
Hi. So we are the next.
Yes. What's your name?
I'm
Matej.
Matej.
Matej. It's not Matej. Because in Portuguese we would say Matej.
Yeah.
It's with
Like-
G.
Maciej in Czech.
Mm,
Like you.
Thank you. Thank you for the explanation.
Or you can use this one here.
Oh, that's even better. What do you prefer? HMI or VGA?
Yeah.
Both.
It's up to you, but there is
HMI.
MJR and
I will use HMI.
VGA.
There's
Internet connection.
yeah.
Somewhere. Yeah, here.
Oh, thank you. Disable Wi-Fi.
And please repeat the question
Okay.
because of recording,
Okay.
and we will show you like 10 minutes before the end. Like it's 10 minutes.
The sign,
Yeah,
right?
here.
Okay.
Like